Okay, so for exercise 2, we want to take these families that we worked on exercise 1 and see which ones are pairwise disjoint. Now, the idea of pairwise disjoint is, suppose that this represents the universe, right? If I have these sets here, the intersection in all these three, the intersection is empty because there isn't a value that's common in all three of them. However, they're not pairwise disjoint because we can see that these two sets here, they do intersect at some value, right? So the idea of pairwise disjoint is that, yes, the intersection between all of them has to be empty. However, between any two pairs, they can't intersect as well. They can't have anything in common. So with that in mind, for item A, we can see outright that it's not pairwise disjoint because we can find one element that's here and then in another set as well. So that's going to be a no. For item B, if we look at them, none of them have a single element in common, right? So that is going to be yes, they are pairwise disjoint. For item C, we're just going to expand these a little bit. And I won't go through the logic of these sets. If you want to go through them in depth, you can look at the previous video, which was 2.3.1. So let me just expand this. So for this one, A1 is going to be the set 5, 6. A2 is going to be the set, let's see, 10, 11, 12. A3, we're going to have 15, 16, 17, and 18. A4, we're going to have 20, 21, 22, 23, and 24. For A5, we're going to have, let's see, 25, 26, 27, 28, 29, and 30. And lastly, for A6, we're going to begin at 30 and then 31, but we don't need to continue because we can already see here that these two sets are not pairwise disjoint, right? You have an element here that also exists there. Therefore, the answer to this one is a no. So that's going to be no. For item D, we're going to have that B1 is going to be the set n minus the index, so it's going to begin at 2. So B1 is going to be 2, 3, 4, and so on. And then B2 is going to begin at 3. So 3, 4, 5. And we can already see that the answer is no because they do have elements in common. So the answer here is going to be no. For E, let A be the set of all sets of integers that contain 10. And this is a no, because if it's the set of all sets of integers that contain 10, we have the set 10 and 1, that belongs to A, right? And also the set just containing 10, that belongs to A. So definitely not pairwise disjoint. In fact, all of these sets there are going to intersect because all of them are going to have 10 in common. What about F? So already here we can see that they're not pairwise disjoint because we can see here that there's one element that's common in two sets. So that is going to be a no. For G, let's see. A1 is going to be 0, 1, 1, and A2 is going to be 0 and then 1/2. So these are not pairwise disjoint because if you say, if you take like a quarter is going to be here in the middle, right? And a quarter is also going to be here. So definitely not pairwise disjoint. So that's a no. What about H? Well, H, and once more, if you would like to look at each of these examples a little bit more in depth, you can go to the previous video. For H, AR fulfills this criteria here, where R goes from 0 to infinity. So if I go A1, that's going to go from -pi all the way up to 1 excluded, and A0 is going to go from -pi to 0 excluded. So you can see here that they all have negative pi as one of the values in common, but in fact they have many more values. So that's also going to be a no. So that is going to be a no. What about I? So for each real number r, it's going to follow this rule here. So if we go, for example, a 0, that's going to begin at 0, and then it's going to go to 2 times 0 plus 1 is 1. And then a of, say, 1/2, that's going to begin at 1/2, and then go to 2 times 1/2. 1 plus 1 is 2. So we can see that these are not pairwise disjoint because the value 1 is included, is one of the values, right, that's included in both of them, but in fact you have infinite values that are in common. So that's also going to be a no. For the next one, J, let's take a look at it. So if we have, say, M1, that's going to be -3, -2, -1, 0, 1, and so on, right? And if I do M2, that's going to be, and I should indicate that these are infinite, it's going to be -4, -2, 0, 2, and so on and so forth. And so we can see that they're not pairwise disjoint because 0 is going to be in every single one of them, right? But you also do have other ones as well. So not pairwise disjoint. So that's going to be a no. What about item K? So we're saying that for each natural number, it follows this rule here, and it begins at n is greater than or equal to 3. So A3, we're going to begin at 1/3 and then end at 2 plus 1/3, 7/3. And then A4, we're going to begin at 1/4 and then end it at 9/4. And we can see that they are not pairwise disjoint because, for example, the number 1 is going to be right in the middle here, as is the number 1 over there. So they definitely do have stuff in common. So that is also a no. The next one is going to be L. So let's take a look at it. So L, for each n belonging to z, so let me, so C0 is going to begin at 0 and then end at 1 excluded. And then C1 is going to begin at 1 and then end at 2 excluded. Maybe we can do C-1 is going to begin at -1 and then end at 0. So you can see that none of these are going to have any values in common, right? Because wherever it ends here, it ends excluded. So 0 is not included there. And then it begins at 0 here. So we can see that right at the edge where they would overlap, one of them is excluded and the other one is included. So for these, they're not going to have anything in common. So that's a yes. And for M, it's very, very similar. The only difference is that the left-hand boundary is excluded. So it would go, say, -1, 0, and then 0, 1, and then 1, 2. So similarly, they're also not going to have anything in common, right? Because right at the boundary where it would overlap, it's excluded from both of them. So that is a yes for item M. Let's do item N. So an example here would be D1. So for this one here, D1, it begins at -1 and then goes to 1/1. And then D2, it begins at -2 and then it goes to 1/2. And we can see that these are not pairwise disjoint. These are not pairwise disjoint because we have 0 that is in the middle of these, right? 0 is included in D1 and D2, among other values. So that is going to be a no. So for each prime number, we're saying NP. So So if I have the first prime number is 2, right? So 2n would be, we're multiplying all the natural numbers by 2, so that would be 2, 4, 6, 8, and so on. And then 3n, because 3 is also prime, we're multiplying it, so it goes 3, 6, 9, and we can already see that it's not pairwise disjoint because they do have stuff in common. So that is also going to be a no.